morning everyone. My name is Megak Abin Zahirul bin Megak Isri and we are from Group 6. So today we will demonstrate an electromagnetic field theory experiment which to visualize magnetic field line using ion filling. We have been introduced with this topic from chapter 14 on electromagnetic field theory course. However, for our experiment, we are focusing on chapter 16, which on a subtopic magnetic flux density. Magnetic field are invisible region of force produced by a magnet or moving electric charge, and this experiment allow us to observe their pattern using a simple setup. So for the experiment, we are required a piece of magnet and an ion filling. Also with a piece of paper so that we can see the pattern more clear. For the setup, first of all, we are going to put the iron bar here, and for the second step, we need to sprinkle evenly a light layer of iron filling around the magnet. So first of all, we gotta gently apply the iron filling.
Hi everyone, my name is Mujadna and I will be briefly explaining what our experiment has shown us. So as we can see, when the ion fillings are settled, we can see that the fillings have formed lines from the one end of the bar magnet to the other end, while there is a lot of ion fillings are clustered around the either poles. This is because we can see that the magnetic field intensity is the strongest when the position is at the either end of the bar magnet. This experiment visualized that the magnetic field lines are created from the North Pole to the South Pole. So just now we have seen a 2D representation when we place the magnet bar on its flat side. So right now we will gonna show you the 3D representation of the magnetic field lines emanating from one side, either the north side or the south side. So when we hover the magnet above the ion fillings, we can see that the ion fillings are beginning to stack on top of each other and get attracted to the magnet. And if I just hover them around in a circle, as you can see, the ion fillings, no matter the position, will get attracted to the poles of the magnet at the tangent perpendicularly.
This experiment highlights two core principles of magnetic fields. First, they are vector fields with both direction and magnitude, and their field lines always form closed loops. Theoretically, this reflects Gauss' law for magnetism, which is B.ds equals to 0, which is confirmed that magnetic monopoles is not exist. Because no matter how many times we divide a magnet, each piece still has both north and south poles. What we can relate to this experiment is it relates to Faraday's law of electromagnetic induction. It means that a changing magnetic field induces an EMF in the loop, a concept used in devices like motors, transformers, and MRI machines. Here, magnetic flux density, which is B, is analogous to electric flux density, which is D. In free space, that B equals to permeability times H, it shows that they are direct proportionally through permeability. So for the conclusion, what can I say is this simple experiment makes invisible magnetic forces visible and reinforces key electromagnetic field theory in a clear and a practical way.